Hello, Evan. Page 52, number 7. Yep. I don't know. This was part of the givens. I don't know if you guys noticed that, if you tried it out or not. So with you guys anyway, this is the second time I've reviewed this type of proof. And looking at the givens, what type of proof is this? Indirect proof. Yep. Definitely a possibility come Monday. Bless you. Definitely a possibility. Okay, we know at least in one of the two first steps, I have to have my assumption. And I'm actually going to start calling on people today instead of just yelling out, because I got to know where you guys stand as far as this midterm goes. Okay, well, in this proof in particular, what's my assumption? Number 2, what's my assumption? Opposite of the proof statement, not an opposite of the givens, opposite of the proof statement. So BD perpendicular to AC. Treat it as a given. All right, so I have AD congruent to DC, and I have BD perpendicular to AC. Doesn't look it. There's a reason why. Okay, what's your goal? Contradict what? Here we go. 23. What do you want to contradict? Well, I don't want. I'm trying to prove that. I want to contradict one of the givens. Which one is it going to be easier to contradict? So let's show it is equal. All right, by showing the triangles congruent right now. All right, I have a pair of sides. What else should I write up here to get the triangles congruent? Let's roll. Here we go. 21. What else can I put up here? Yep. Okay, I got a reflexive side BD. I've marked the diagram, but I haven't put it in my proof yet. And what is that? Here you go. 24. What else should I put up here?
Angle BDC and angle BDA are right angles.
Why? Yep. And then I'm not going to ask anybody this. Hopefully we know we got to say they're congruent. Okay, give me a method why triangle BAD is congruent to triangle BCD. Why are those two triangles congruent? What method do you have for me here? Here we go, 22. Side angle side, looks good. Now we know what two sides are congruent that we wanted to contradict. AB congruent to BC. CPCTC. And now what do you have in your givens and in step 7 now? What are we calling these here? In your given and step 7. Contradiction, which means what about our assumption? It must have been false, meaning BD is not perpendicular to AC. Assumption led to a contradiction. And again, please make sure you tell me what lines the contradiction's on. How's that look, Evan? Indirect proof. Nathan, did you get a fresh cut? Looks good. Professional or homegrown? Do you get a say in it? Full say, 100%, or half say? Full? Do you like the way it came out? Not bad. Is this like an all business midterm cut? All right. It looks good.
Can you do page 9, 3C?
Didn't want to keep talking? Okay. It must have been an all business cut. Page 9, 3C. I feel like we went over this one. Maybe it's another class. It's fine. I'll go over it again for young Nate. Ready? Non-coplanar. Can't be on the same plane. So you could give me 4 points. 3 of them could be on the same plane. But as long as that other one's not, it's not. All right, so here you go. Ready? A, G, F, C. Even though A, G, F are all coplanar, C is not. So those 4 together would not be coplanar. Okay, so just give me 4 that aren't on the same plane. We all right? Sure. Okay. Maybe I'll do this one again tomorrow too. And then there'll be no coplanar questions on the midterm. Topics. Anything here. Topics. Don't be afraid to speak up. Because if you ask it, I'm sure somebody else wanted to ask it, but just didn't want to speak up. And if they don't want to hear it, who cares, right? This is your midterm. Hi, James. 74, going deep. You got to remind me of the number again. A little isosceles trapezoid. What was this, guys? Page 74? Okay. Okay, DE is parallel to GF. Got it. DG is congruent to EF. And what are we looking for? Find all angles. Whew. Going hardcore here. Find all remaining angles. All right, let me turn it over to you. First of all, let's review. Even if I don't need to use it, let's review the properties of an isosceles trapezoid. Legs are congruent. I got it. What else should we know? Let's see. And we should know probably 2 more properties, regardless if we use them here or not. Those 2 properties, base angles are congruent. And when I say base angles, I don't just mean the 2 bottom ones. I'm talking about these 2 are congruent right here. And D and angle DEF are congruent. Base angles are congruent. And you remember anything about the diagonals? Diagonals are also congruent, but they do not bisect each other. That's the parallelogram family. It's isosceles trapezoid, not part of the parallelogram family. All right, let me turn it over to you guys now. Find me any angle now. Find me any angle. And be ready to tell me why. 17, want to start off? Okay, angle EGF, 30 degrees. Alternate parallel lines apply. Alternate interior angles are congruent. Got it. We got 1 angle down. Give me another angle you can find and why. Don't have 1. Where are you? You're slacking big time. 24?
Angle FGD is 45.
45. How do you have that, young Saad?
Because angle DGF and angle EFG are congruent.
Base angles are congruent, everyone. So if that's 75, this whole angle's 75. Part it was 30, the other part's 45. 20. Yep. Why? Okay, we could go that way too. And also, it's also part of a triangle where you know two of the angles already, and the third one will add up to 180. Okay. One more angle, GEF. I'm looking for one more angle, GEF. 22, GEF. How'd you get it? Yep, angles add up to 180 in a triangle. Or you could have said base angles are congruent. So these top two base angles had to both be 105 degrees. James, how are we looking? Good. Good to hear. Good question there. Little quadrilateral properties. I like it. How awkward or how frustrating is this right now, huh? Definitely a little quadrilateral property on that problem. Another quadrilateral. Distance formula. Oh, there's the word midpoint. Oh, more quadrilateral. Wow. These last couple pages, I just counted. Here you go. I just counted. Let's see. 1, 2, 3, 4, 5, 6 quadrilateral property questions in 3 pages of the midterm. Wow, there's that word centroid. Hi. Page 50, number 3. Equilateral. What do you know about the sides of an equilateral triangle? G is a centroid, meaning it's the intersection point of all 3 what? All 3 medians. So if I draw a median from A down to CB, what's a median do again? Medians go to midpoint. So it's breaking this up into 6 and 6. Everyone agree so far? It's asking us to find the length of AG. Well, what do you know about the centroid? Splits it up into a ratio of what? 2 to 1. So I know, ready? I know 2x plus x equals the length of the whole median. Are we all in agreement with that statement? 2x, this part here, plus x, this part, equals the length of the whole median. What I need your help right now is what is the length of the entire median? Because I can put it here and now I have an equation to solve. So what is the length of the entire median? Ready to help me out? Look at, everyone see the 2 triangles I've created by drawing in the median. Anybody know anything about those 2 triangles? 6, 6, 12, 12, shared side. They're what? Congruent by side, side, side. Meaning, and I know I'm taking this deep, but it's an honors level question here. These 2 triangles are congruent. What do you know about these 2 angles? They're congruent, and they also add to what? 180. So they have to be what type of angles? 90. Does anybody see where I'm going here? How you could find the length of that median here? Pythagorean theorem. Yep. All right, so help me out with Pythagorean theorem right now, and that'll be 6 squared. What's the 12 acting as, a leg or the hypotenuse? Okay, good. So b squared, I'm going to put m squared for median. All right, hopefully that doesn't freak you out. So we're trying to find the length of the median so I can plug it into my equation. So 36 plus m squared equals 144. Move the 36 over. What do you got? M squared equals 108. That's not a perfect square, but I prefer you break it down for me. All right, to get a little practice, break down the square root of 108. When you find the biggest perfect square that goes in the 108, let me know. 36, and what do you multiply 36 by? Yep, so the median length is 6 radical 3. The entire median has a length of 6 radical 3. So now I can say, all right, 2 to 1, I know when I add those together, I get 6 radical 3. All right, 3x equals 6 radical 3. What do you want to do on both sides now? Divide by 3. And when you divide by 3, are you dividing the radical by 3? No. What's the only thing that gets divided by 3? What's the only thing that gets divided by 3? 6. So it ends up being, is that what I want? Is that going to be the length of A to G? No. Why? Because A to G is the 2 part. Right? This right here from G down to the midpoint is 2 radical 3. What do I have to do to find AG? Take 2 radical 3 and do what with it? Multiply it by 2. So the length of AG will be 4 radical 3. Lot to remember there. Starting off, again, G's the centroid. How's the centroid form? Intersection of the, so it's got, G's got to be on a median. That's where you got to start this problem off. G has to be on a median. And then knowing the fact that it breaks it up in the median up into 2 to 1. Yeah. Good question. It's the 2 part in 2 to 1 is always from the vertice to the centroid. Always. So if I drew from B here, BG is the 2 part, the other part's the 1 part. It's always from the vertice to the centroid is the double part, the bigger part. Okay? Anything else you want to cover here? Yep.
Is like when reviewing for the midterm, do I have to?
When reviewing for the midterm.
Do I have to look at old packets or anything, or is this enough?
That's your call. Whatever you think is going to be enough. Here's, because if you see how I set up the packet, the start of every unit, look, if you know those without going back to your packet, fine. If you don't, you got to go back to your packet. Got to research online somewhere. Okay? Theorems. Okay? That's why I started every unit off like this. Do you know those vocabulary terms? Do you know those theorems and how to apply them? Can you draw a diagram if necessary? If not, then yeah, I guess you're going to have to go back to the packet or look it up somewhere online. Okay? Hi, Joanna. 51. Put the 5 segments in order. You got it. This was which page? Page 51. All right. First thing I would do, find the remaining angles, which I guess looks like most of you are doing right now. We got 38 here for this one. And what are we looking here for angle N? 40. 3. Okay. Before I start this problem, what theorem are we going to apply here? Largest side in a triangle. Largest side is across from the largest angle, or in a triangle, smallest side is across from the smallest angle. But it's in the entire diagram. So what I need to do right now is I need to take both triangles in that diagram and list their sides from shortest to longest before I can determine the entire diagram. So let's start with MLO. I need the sides from shortest to longest from somebody. Shortest to longest and MLO. 12, go right ahead. Shortest side. LO. Next. ML and the longest side. MO. Thank you. Ready to go? MNO, everybody. MNO. Shortest to longest for me in MNO. How about 10? You're going to list them for me? MO, yep. MN. NO. All right, we ready to list them in order? What is the shortest side in this diagram? Well, it's a toss-up between LO and MO, because those are the two shortest sides in each triangle. Which one can it not be? MO. Why? Because there's two, look right here. There's two shorter sides than MO. So what's the shortest side in the diagram? LO. Okay, that's gone. What's shorter, ML or MO? Which one? ML, right? It's right here. Showing right here. It's still the shortest side, ML. What's up next? Now it's MO, yep. And now we can go in order. Next side, MN, and the longest side in that diagram, NO. Yes, Nate? MO twice? Well, there's only 5 sides in this. Okay. Yeah. Will they, meaning me? Yes, I will. Okay. There's no reason to write MO twice. Okay. Anything else? How? Frank, here we go. Hello.
Can you do page 71?
Kid's going deep again. It must be quadrilaterals. Okay, Frank, what type of figure is this? A rectangle. Yes, it is. First question is BAD. Why is BAD congruent to CDA? Okay, you said it was a rectangle, right? Opposite sides congruent. Good. Right angles. Agreed. And they share this reflexive side. So this is not the only way. You could say side, angle, side. Anybody see any other methods I could do? Because I just picked that one. We could do more. What other methods could I do here? What do you know about the diagonals of a rectangle? Diagonals are congruent, so I could also go side, side, side. Let's see. I could also go, it's a right triangle, HL. Yep, could also go HL if I wanted to. Let's see. Could I go angle, angle? I'm trying to figure out if I can get any of the angles in there. That one's congruent to that one. Probably could, but it'd take a while, so I'm just going to leave those. All right. Good on those 3, Frank. Why? Yep. Well, Matt, here we go. That's all I would need there. State of reason. Yep, one of the 5 reasons. All right, you ready for the next one? All right. Everybody good? I'm going to get rid of all this. Okay, CAD. Where's CAD? Right here. 3x minus 22. And BDA, this one right here, x plus 14. And I'm looking for AED, this one right here. All right, here we go. There was another property of a rectangle. Because the diagonals are congruent and they bisect each other, what should I know about BE, EC, ED, EA? Remember, diagonals are congruent and they bisect each other. So what should we know about the four pieces? They're congruent, and you remember the other property I had you guys write down during the unit, the diagonals form four isosceles triangles. Why is that important? What's across from those congruent sides? There it is, congruent angles. So 3x minus 22 equals x plus 14. And now I'm solving for x. So 2x equals, what are we looking there? Add 22. 36. So x equals 18. What's your plan of action now? Because I need to find angle AED. Plug it back in for 3x minus 22 and x plus 14. And then all three angles add up to 180 degrees. All right. Okay, here's what I'm going to do right now. I'm going to talk about the two courses that you have available next year to take. I'll answer any questions that you guys have. You have a whole week to think about it, discuss it with your friends or your parents. You know, if you have questions for me, obviously ask me too. But next Friday, we'll make a recommendation of where you want to go next year. All right, so here we go. This isn't not like art or tech where there's a lot of choices here. We got honors geometry BC. That's where you guys are right now. All right, you got two options next year. Okay, not one's better than never mind. You got algebra 2 AB. And you got honors algebra 2 BC. No matter where you go next year, if you're a freshman anyway, you're still going to be considered accelerated. Okay, you'll be a sophomore in a junior level class. Okay, difference between the two, heck of a lot harder. I don't know if you guys have any, I know the answer to this, but if you have any friends that take honors algebra 2 BC, ask them, how is this class? And they'll tell you it's pretty tough. Okay, algebra 2 AB is a little bit lighter, but again, both of them are still 1 year accelerated if you're a freshman. All right, where does it go from here? Junior year, you would take honors pre-calc, and senior year, if you chose to do so, it would be calculus BC, excuse me. Okay, over here, you take pre-calc AB, your junior year. I'm talking freshman here. Pre-calc AB, and then you would take calc AB. So either path you take, if you're a freshman, you can still take calculus your senior year, if that's your end goal with you and your parents. Okay, if that's your end goal. I will let you know, somewhere along the way here, we start drifting here and everybody ends up in calc B. Maybe you get 12 to 15 people that are in honors geometry that end up in calc BC, but most of the people end up in calc AB because they struggle somewhere in this department right here. Okay, so those are your options for next year. This is my only piece of advice to you. Don't pick it because of the name. pick it because you're going to be successful in it next year. Okay? Don't pick it because it's got honors and you think you're high and mighty and a Mr. or Mrs. Big Shot. No, pick something next year that you think you're going to be successful in. And the best way to do that is, again, talk to people who are in this course right now if you can. They will tell you probably how difficult it is. Right? You can believe me or not. Just because you're doing well this year doesn't mean success next year either. Okay? And when we talk next Friday, I'll tell you what I think and what you will be successful in. Okay? So again, just don't pick something because of the name. Right? Also think about the other classes you're going to take next year. All right? Are you going to load up on AP honors level classes, including this one? Okay? Everything looks great in January, and then come September when you actually have to take those courses and you're like, whoa, what did I sign up for? All right, so think about that too as the rest of your course load. All right? Anything I can answer for you guys about these two courses next year? Again, if you're a freshman, they're both still at 1 year accelerated. Okay? The only difference is you'll be going towards Calc AB versus Calc BC. But again, like I said, most people sooner or later start hitting this way somewhere. Okay? Because something gets a little too difficult here. All right? Yeah, what's up, Evan?
Is there trigonometry involved in Congruent?
There is 2 units of trigonometry, yes. And that's no matter what course you go to. Yeah, there's 2 units, 2 big units of trigonometry. And what he means by trigonometry, sine, cosine, tangent, we have a trigonometry unit coming up after the midterm. Okay, so we'll do a little bit of it. Anything else? Questions? Think about how you did last year in Algebra 1. That might be a good also landing spot for you next year, how well you did last year, because you're going back to algebra. Anything else here you want to ask about the courses next year? So think about it. If you want to come in and talk to me, I'll answer all your questions. But again, if you can find somebody that's in Honors Algebra 2 right now, they'll tell you the big difference between this year and next year. Okay. Definitely, and I'm not talking to a lot of people in here, definitely if you're lazy, you will never succeed in Honors Algebra 2 next year. You can succeed in this class and get by being a little lazy, but not next year. Definitely not next year. All right, you'll sink. Any questions? Okay, I'll give you guys the rest of the time to review. I'll walk around. If you want to ask me questions individually, feel free. Okay, but please be working on some midterm stuff for this class.